I don't really know what to do about that. Hey, Patrick. I can't hear you. I can hear some static. And when I'm looking at the screen, I see the volume going up and down. But I can't hear you. Can you hear me?
You there?
Oh, yes, I can hear you.
So weird. Sorry. I was on another thing and I just checked back on Google Classroom and then I saw that you'd replied.
Oh, okay. Yeah. Do you have a specific question?
Yes, I did.
Okay.
So on the end puzzle, I just kind of stopped at the first question. I don't really understand the whole literal equations thing and how in the video they just move all the letters around a whole bunch of times. I don't really get why they need to do that because you could just plug in the numbers.
Yes. And I understand what you're talking about with regard to that. But one of the reasons that we do this is later on in science, you have to solve for so many different variables. So like, let me give you, for instance, like this is a legitimate, and I don't remember whether I did this in your class or not. I don't think that I did yesterday, but this is a fairly simple science equation for physical science. I don't know if you've had, I don't know if you've had any type of science equations as of yet.
Yeah, we did last year, I think. Mr.
Okay.
just threw one at us to see what would happen. So
Yes. And one of the other things is a lot of times when you're working in geometry, which is what you will have next year, you have to solve for different types of variables, given some information. So like right now, they've got speed equals distance over time. So what they're talking about for literal equations is they want students to be able to solve for any one of these variables. So what they do in math, on the math side, because we're working toward being more of a, a STEM like school, and also society's kind of moving that way. Also, everything's very technological. What they're doing is incorporating math so that at any point you can solve for any variable. So that's why the literal equations are there, in order to help you use all of the same algebraic principles that we've used thus far this year, using, the working the order of operations and working that and putting them in reverse, unpacking them, if you will. But stripping all numbers really out of the situation first, and seeing if you can solve for any type of variable within an equation.
Sorry I didn't get on the first time. I have taken 2 trips to my ENT office today, and I was literally waiting to get on. It was almost 3. Then my dad's like, oh, we need to go pick something else up, because I had just gotten back like 30 minutes before that from the ENT office, so got back from it again.
Oh, bless your heart. Well, it's okay. It's okay. Y'all were kind of having to work around me today as well.
Yep.
So, we all just kind of that's kind of the whole point of the university modeled school is we've got things that we need to do on our off days. So y'all were patient with me. So I'm more than happy to, work with you guys. So it's not a big deal.
All right.
Appreciate
let me
it.
pull up the Ed puzzle problems. Even though I got to the first question, it is telling me I need to watch a few more seconds of it before it will give me the question again. So
let's just quickly check and make sure that works.
Come on, thing.
Minus 5
All
times
right.
3.
I have the question. The mastery question, the mastery check, whatever.
Okay.
So
do you want to read it to me?
Yes, that's what I was gonna do.
Okay.
AX equals BX plus C. And then use the solution to solve 11x equals 6x plus 20.
Yeah, I think that's actually, believe it or not, here's the blessing. This is one of the guided practice problems. So make sure you do take notes because then you'll have the guided practice problem done. If I'm not mistaken, let me just double check real quick. I believe that it is.
Yeah, I'm pretty sure I completely failed the guided practice. I
am absolutely, yes, this is number 2 on page 126.
Okay.
So this was actually the harder of the two of them. Because you have to use the distribution property in reverse. But
hello? You there?
Yes, I'm here. Can you hear me?
Yep. It
Okay.
just cracked out for a second.
So what I want to do is what they're asking us to do is to solve for x. So what I'm going to do first is get all of the x's on the same side. So I'm going to subtract bx out from both sides. And that will eliminate it from here. And then over on this side, I'm going to have this. Okay?
Okay.
All right. Now, on this particular one, I don't have any idea what A is, and I don't have any idea what B is. So I really can't combine like terms, technically. But what I can do is use the distributive property to unpack AX minus BX. I can divide both of those by X. So if I take the X out of AX, it's going to leave me with A. And if I take the X out of negative BX, it's going to leave me a minus B.
Okay.
Equals C. All right?
Yeah.
Now, to get X all by itself, I'm going to divide both sides by A minus B. And then that's going to leave me with X equals C over A minus B.
Okay.
And then, I know when you're given these numbers, it's like, it doesn't really make sense to do all of this. But really, it's to train our brains that no matter what, when they ask us to solve for a variable, we literally can solve for any variable in an equation, whether there's numbers or not. And that's really one of the things that we need to be able to do for lots of different reasons. And we're going to be making number 3 in the guided practice is definitely an application we'll continue to use for the remainder of the year. But so the next step on this part is we're going to identify the values. By that, I mean like whatever number it is for each one of these variables. So A in this equation is 11. Does that make sense to you? And B is 6. And C is 20. So now what I'll do is plug that back in here, and I'll have 20 all over 11 minus 6, which equals 20 over 5, which equals 4. Yes.
All right.
So that's the principle behind that. And it seems kind of strange, but it's definitely something that you were going to use. Believe it or not, we do it when we use Fahrenheit and Celsius. We use it when we're doing all kinds of things.
Yeah.
And then does that help you a little bit more with the video?
Yes.
Yeah, I love that you want to know why. And it's really, really good. Not every student knows why, so I don't spend a lot of time in class always explaining that stuff, but I love that you want to know why. And I appreciate the fact that you're asking. But to be able to unpack any complicated formula to isolate one particular piece of it is very crucial.
Mm-hmm.
Do you want to do any more of the guided practice?
Here, let me just do one of the guided practice problems. Let me pull up HRW. Give me a second.
Okay.
$126. So dumb how HRW, when you first open the book, you have to go to a chapter before you can put in a page number.
I know. There's a lot of things that I would like about their website to change.
All right, here. I'm going to do number 1 because we just did number 2.
Okay.
So pull out my piece of paper that I did this on.
Did you write down all of that stuff so I can start erasing? I don't want to erase it if you still need
I took a picture of it on my phone.
Oh, good for you.
All right. So let's see. So that would be a minus bx equals c. And then we need to solve 12 minus 5x equals negative 3. So for this, wouldn't we just need to take, subtract? Wait, since there's only one, wait, I think I wrote this wrong, yeah. Forgot one of the x's.
No, you wrote it right. This one's actually easier.
I'm looking at number 2 now. So a minus bx equals c. So since we only have one x, then we don't need to get all the x's on one side.
No, sir.
So,
but we do want to get rid of the a being close to it.
So we divide a by both sides?
Well, a, what is the understood sign out in front of a?
Positive.
Yes. So what you're going to do is actually subtract it from both sides because it's not being multiplied by this bx. It's actually, the ax is positive and this is a minus bx. But in order to get a to the other side, you need to subtract a from both sides.
So it's
just like it was a number.
Equals negative bx.
So you'll have this equals, and then c minus a. Yep. And now negative b is being multiplied to x. So how do you undo multiplication?
You divide.
So I'm going to divide both sides by the opposite of b.
Okay.
And so that's going to leave me this. Now, when you're plugging in your values on this one,
all right, so I have that. So now let me go back to the, I wrote it down. So for this one,
A equals 12. And B, this is one little caution on this, because we kept that opposite piece, the negative, in our literal equation, you only have to write that as a 5 because this opposite sign is actually accounted for in the literal equation.
Oh, it is. All right.
So that's kind of a special thing.
Okay. So then C would be -3, right?
Yes, sir.
All right. So then so C -3 minus A. So that would be a positive. 3 minus 12.
It's -3 minus 12.
Well, yeah, sure. I put a double negative on it. I don't know why. -15. -15 over B, which is -15 over 5.
Oh, -15 over the opposite of B, which is going to be -5. So it's -15 over the opposite of 5, which is going to be a +3.
All right. Well, that's not that hard.
It's not that bad when you understand why they're having you do it. So, so that when you get into physical science, when they say, hey, I want you to solve that for T, you would multiply both sides by T.
Mm-hmm.
And then you've got S, T equals D. And then you're going to divide this by S. And so then you've got T equals D over S. And that is going to happen.
Yeah.
And so then they'll be like, okay, so now if you're given distance and speed, then you can figure out what the time is that it's going to take you to travel somewhere. And so those types of, and matter of fact, they're actually doing that right now in 9th grade physical science. So, but that's kind of the reason. That will also help in geometry when you have like volumes of spheres and cones and cylinders and all those funky shapes that that you're going to be working on. Because sometimes, you'll be given the height and sometimes you'll be given the base or one of the small bases, which then you've got to figure out the area of one. So you're really having to pick apart and take apart pretty intense equations. So this is kind of the intro to that. More importantly, for our purposes, number 3 on the guided practice is something that we're going to be
about to ask. What do you
okay. Good. All right. What you were going to ask? Could we do that one?
Yeah. What do you do for that? So I have a small idea of what that means, but what do you do? Do you need me to read the problem?
Oh, look, I got logged out. Yay. Let's see if it takes me back to it.
I doubt it.
Yeah, maybe that would just be quicker for you to go ahead and read it to me if you don't mind.
All right. It is write 5x plus 4y equals 20 so that y is a function of x.
Okay. So that means they want us to solve for y.
Okay.
Okay. And so, and you will be doing this a lot. Perhaps beginning the next chapter, but definitely for the remainder of this year. One of the main reasons, and I know y'all were introduced to this last year, but when you're trying to get an equation into y equals mx plus b format, do you remember that by chance or no?
I do.
Okay, so you will be doing that a good bit. So what you're going to do to get to that y, you've got to undo everything. And what I like to think of is you're working your way toward the y. If there's anything over here, what you're trying to do is get to here. But you also have to bear in mind that you're working with the order of operations, so you need to work that in reverse. So I have to get the things around that 4y out of there first before I can start dealing with the 4y. And I know that the 4 is being multiplied to the y, but I need to get everything else kind of on one side first. So
Yeah.
the understood sign in front of this 5x,
That's positive.
so I am going to subtract 5x from both sides. And so then that's going to leave me with a 4y equals 20 minus 5x. And now the y is being multiplied by 4. So how do I undo multiplication?
All right.
Is division.
Mhm.
So I'm going to divide both sides by 4. And then that will leave me with y equals, and then 20 divided by 4 is 5.
Mhm.
And then here, I just am left with a fraction, which is okay. And so now this equation is stated as a function of y. Y is a function of x.
Mhm.
It could also have been written like this, which really is almost our, mx plus b format. Either way would have been correct.
Okay. All right. Thank you.
Not a problem. Do you want me to do number 4 with you
Yeah,
while we're here?
look at number 4. I think number 4, that is pretty easy. I mean, number 4, I got 2.4 for
Yes.
Yeah, that wasn't that hard. I mean, I plugged it in my mind mostly, so.
Yeah. Were you able to solve the formula for the W? Or did you try that?
Well, solve the formula for the with the W. So.
Yeah. Like to actually write that formula down and then get the W all by itself.
No, I didn't.
Okay. Do you want to see that done?
Sure.
Okay. It's just more practice of watching somebody take a literal equation and be able to solve it for any variable. And that's the whole principle behind this, is just that practice of unpacking.
Yep.
So the perimeter is 2L plus 2W. And what they're asking us to do is solve where the W is all by itself. So once again, I'm going to unpack everything around it. And then eventually I'll have 2W by itself. But I need to get rid of this 2L first, because I have to do PEMDAS in reverse, and addition and subtraction comes first. So I've got P minus 2L equals 2W. And then to undo multiplication, I divide.
Mm-hmm.
So now I'm left with P minus 2L all over 2 equals W. And the temptation might be to get rid of those 2's, but we have to remember anything above or below a denominator, or a fraction bar. So if it were in the numerator or if it were in the denominator and it's a grouping, it has to stay together like a family. So you can't undo it. It has to stay just like that. So then from there you would take what you know, which is the 19.2 minus 2 times 7.2 divided by 2. And you've already got this part really figured out. It was 19.2 minus 14.4 divided by 2, which that leaves you 4.8 divided by 2, which W equals 2.4.
All right.
Which you already found that out, but that's how you do it the way they're asking you to, which it seems like a lot of engineering, if you will, to go around that. But like I say, it's a crucial skill to gain, to manipulate around science and graphing. You're going to do a lot of this in graphing. So, all right. Hope that helped.
All right, thank you. Yes, it did. All right.
Okay, good. Have a blessed afternoon.
All right, you too. Thank you so much.
Bye-bye.
See you in class tomorrow. Bye.
Bye-bye. Okay.